Okay, then let's get started. So, we changed the name and the content of this talk about 5 million times. So it's only a slight variant from what's in the program now. Instead of how we learned to stop worrying and love the browser, we realized we didn't love the browser, but we do love JavaScript. Um, that's the new title. So myself and Angus, who'll be talking in a bit, are both on the web team at Twitter, and we've been really, really busy. Some of you may have seen this thing being talked about on the web. This is part of the work we've been doing, and we've actually completely re-architected Twitter.com, and we're rolling that out now. This article talks about the performance, but what we don't really talk about in here is the fact that we use this opportunity to basically rethink the whole of our front-end architecture, not just from a performance point of view, where we render content and all of that kind of stuff, but actually even right down to the basics of how we structure our code. When we started doing this process, we had these two principles in mind. The first one is, always seek to use the right tool for the job. There's a lot of temptation these days, and it happens quite a lot that people tend to, JavaScript all the things. If all you have is a hammer, everything looks like a nail. And we know that there's not just JavaScript as a tool for creating web applications, but there's HTTP, there's HTML, HTML5, and all kinds of things that you can take advantage of. And we want to make sure that we use the right thing. Secondly, and the thing that we're going to be talking more about in this presentation, is that we want to make sure that we take advantage of our environment, which is the browser, obviously, and JavaScript. We want to work to their strengths rather than trying to impose some other paradigm on it. This kind of reminded me of this old Bruce Lee quote, "Be water, my friend." What he's trying to say is that if you pour water into a teapot, it becomes the shape of the teapot. Similarly, when we're thinking about how to solve problems on the web and in the browser, we want our approach to the problem to become part of its environment. We want a JavaScript solution for our JavaScript environment. Now, we were originally thinking about talking about several of our patterns, but it turned out we really wanted to talk about just one of the most interesting ones and how we applied this be water philosophy. And the thing we wanted to talk about was reuse patterns. How do we write good, reusable, encapsulated code in JavaScript? There's many ways to do it, and I think, at least from my point of view, everything that I tried up until now had felt really awkward. But what we're going to show you today is a new technique, newish technique, or new application of some techniques you may have come across before, that've actually made writing structured and reusable JavaScript code really, really nice. So with that, to explain how we got to that, I'll hand you over to Angus.
So just before I start, I'm pretty nervous because I have a stutter, so I hope you all understand me. It's also my first presentation, so I just wanted to say that first. Okay, so I'm going to talk about the reuse patterns we ended up using at twitter.com, but before we get there, I'm going to walk through some of the other patterns and how those things work. So this was the difficult bit. So 2 weeks before, we were due to present, I thought, oh crap, I need to make an example and use this example throughout the app. And every time I looked for a JavaScript inheritance example, it was talking animals every freaking time. So it's like, so I sent this tweet out 2 weeks ago, can someone help me? Any other examples? And then I got a tweet back from this guy, Chris Ruppel. It's hard to take that request seriously from a large car large cow avatar speaking words into my feed, which is a good point. And then there was another tweet from Rob Sayer, who's also on our team at Twitter, saying, "Why do you hate animals?" And that got me thinking. I actually like animals. I really like animals a lot. And he had a good point. So, talking animals it is. Now, I can safely say this is the most complex slide you've probably seen at the whole conference. And I don't expect you to understand it first time. So, don't be shy. I'll be here afterwards if you want me to explain that to you. Okay, so let's get serious. So prototypes. So in JavaScript, prototypes are the main agent of reuse. And they're very powerful. And I think we're going to show later exactly how powerful they are. But they're also awkward. Like syntactically, they're hard. And, you know, they're called prototypes, but in JavaScript, the new constructor syntax really encourages it to use them the same way as you'd use classes, because you need a type beforehand. There is the create object syntax, or the object create syntax, but basically hardly anyone uses that syntax, partly because of the cross-browser support issues. So basically, JavaScript prototypes are the same as classes to all intents and purposes. And they're also single-rooted, which means that you only have one hierarchy. Everything has to belong in the same hierarchy. It's only single inheritance. And the inheritance syntax is not great. Here's an example, and you've probably all seen this one like hundreds of times. So now we have a walking animal, which extends animal, and the two salient lines are the invocation of the supertype constructor from the subtype. Run this constructor in my context, and also start off with the prototype of the superclass and then extend it. Some people don't like assigning an instance, like I've done here, because sometimes they require arguments. And also, like, do you really need to create an instance just to make prototypical inheritance work? The other way to do it is just to clone the animal prototype and copy it. But either way, it's not like great. So rather than use prototype syntax, you might want to use class syntax, especially if you're from a background like Java or C++ and it's very familiar to you. And in fact, in ES6, there is a class syntax coming. JavaScript reserved class extend and super right from the start in case this ever happened, which means although there are libraries that write their own versions of class syntax which you can use, they're not able to use the class extend and super keywords. And in general, it's kind of gnarly. It's kind of a leaky abstraction, a lot of these libraries. They're using terms like constant static, which are borrowed from other languages, but don't really apply to a dynamic language like JavaScript. That leaves me and quite a few other developers feeling uncomfortable about using those kind of idioms. And in particular, the relationship between this and super is a difficult one. Here's a couple of examples of libraries that are out there. So the prototype.js library, actually, if you want to use super, you need to pass it as the first argument, which is kind of weird, and also means they need to pass all the code beforehand just in case this $super argument is there, and then remember to strip that from the arguments when they actually process the function. It's a lot of extra work they have to go to, all because JavaScript is a dynamic language. It doesn't really fit, or the JavaScript infrastructure doesn't really fit with classical inheritance. It's like trying to fit a round peg into a square hole, if that's what the expression is. And let's also look at another one, which is Dustin Diaz's class library. it's a pretty cool library, but again, he's forced to do some slightly unorthodox things. The context here, his is basically the alien. That it's nothing to do with the function here. So in order to do this super, he has to rewrite on the fly what the implementation of super is going to be based on the function it actually appears in. So again, a lot of extra work going on behind the scenes, potential for error, just a lot of stuff we shouldn't have to do. So even if that wasn't a problem, and when ES6 comes along and we have a nice class syntax that we can use, do you really want to use class hierarchies? Here's an example from the animal kingdom. So we have animal, superclass, subclasses, walking animal, flying animal, swimming animal. It's all pretty nice, and a cat is a walking animal, and you've all seen this one loads of times. That's all great. But wait, the crocodile comes in. And he said, what the, oh, I can't say that. This is a professional conference. But he says, I walk too. I don't just swim, I walk too. So what am I? I'm a subclass of swimming animal, a subclass of walking animal. Therein lies the root of the problem. And then the duck comes in, and duck says, where do I fit into all this? Turns out he's actually all of those things. In a nutshell, that's the problem with trying to model your objects using a single rooted inheritance hierarchy. So this is it. You require upfront knowledge of the general case. The superclass is the general case. That's the abstract case. But really, when we code, we start with the special case first, and then we build abstractions. Classical model kind of forces you to do the other thing, which is why we tend to break hierarchies often and have to change our mind and then get locked into patterns where we can't really change. So is there any other way? Do we need to classify? As far back as the 19th century, British philosophers Whewell, I think that's how you say it, Whewell and Jevons argued that there are no objectively right classifications. And many of you have tried to classify objects in your code would probably agree with that. It often just does not fit. And like, why should I assume that I inherit all the properties that my type inherits from? And then I read an interesting article by someone at the Nokia Research Center, which said, and he was talking about prototypes here, and I don't have a computer science background, so I was uncertain what the real meaning of prototypes were. I looked at this article. He said prototypes are not about categorization, but exploiting a likeness. What do these objects have in common? Not what are they, but what do they have in common? So there's a way we can free ourselves from the constraints of hierarchies, because after all, JavaScript has first-class functions. You don't need to depend on the functions from your hierarchy. Any property can be assigned to any object. That's where mixins come. Simple mixin. You may well be familiar with this. This is an object hash, basically. And it defines some functions. And then the idea is, using extend, you copy every property from your mixin object to your target. And here's an example. So now we can see we're mixing into crocodile prototype. So now crocodile prototype can use the functionality of both walking and swimming. So it's a way to affect multiple inheritance. That's if inheritance is the right term here. So now we're free from the hierarchical constraints, and to me this is important. We're grouping functionality not by what it does, not some arbitrary classification which probably doesn't apply to the code we're trying to model. But there's still a problem with this approach. The mixin doesn't know anything about the source object that it's trying to copy to. So there's a danger you're going to clobber the objects. And therefore, if your target object wants to use a mixin, it needs intimate knowledge of the mixin it's going to use. So to protect the functionality that's already defined on the target. So this is one approach to mixins. Didn't quite work for us. So we looked at a different kind of mixin, which is a functional mixin. Very simple, fits with the language perfectly. Functional mixin is a function, and you run that function in the context of the target object, the thing you want to mix the properties into. You simply call or apply on that mixin function, and then you've obtained the properties from the mixin. Here's an example. Looks similar at first, but it's now a function. It's not an object hash. You see the context here. This value represents the target object that you want to mix into. Now, crocodile, prototype, a special method, for instance, that only crocodiles inherit, like that only crocodiles implement, like stalked tourists, for example. So it's the kind of thing that crocodiles do. And then simply call the mixins, call the with walking mixin in my context, call the with swimming mixin in my context. Lo and behold, now your crocodile prototype has those properties. There's a lot of extra features you get from functional mixins you don't get from object mixins. One is this thing we call a device, which is basically a mixin of its own that adds before, after, and around functions to your target, which means that I can now, in a kind of AOP style, I can mix in, instead of clobbering the target function, can augment the target function. Mixin can add its same named function before, after, or around the corresponding function of the target. Let's look at an example of this. So here's the mixin at the top. This is the advice mixin. That's adding before, after, and around to the target object. Thing about mixins that's cool is anything in the target object is available to any mixin too. They're all the same thing. And then we're going to have a functional mixin called with flu, which is basically going to give the flu to whichever unfortunate animal we decide to give the flu to. And now, not all crocodiles are actually sick, right? I mean, you might think they're sick because they've got these huge, like, sharp teeth and mouths, and they eat people, but they're not really sick. But we're going to choose one instance. And this is key because now we're mixing in, and this is what functional mixins can do, not to the prototype, but to a single instance. So now we're creating a sick crocodile instance. We're calling with flu on the sick crocodile. Now notice what with flu does. It augments the walk object of the target, so every time the crocodile walks, something else is going to happen beforehand. So we make the sick crocodile walk, and instead of just pad, 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 it goes sniff, pad, 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 pad. Here's a more real world, or I guess a more artificial world example. This is what we do. One thing we do at Twitter, on the Twitter.com site, we have a tweet box object, and we mix in a character counter. And there's an initialize method on the tweet box. And we're going to augment the initialize method on the character counter mixin, so that whenever, immediately after the initialize is called on the tweet box, we're going to add a little bit more functionality, which is specific to the character counter. So we're going to assign an element to the counter property, and then we're going to listen for the text updated event on the tweet box and update the counter. So this is an example of a very unobtrusive mixin that doesn't really care what the target object does. It can safely augment the functionality. To summarize, functional mixins, they're verbs instead of nouns. I think this is kind of important because mixin is a process. It isn't an object. Why do you need an object hash lying out there somewhere which is never going to be used as a standalone object? So we're making it a process, and mixins are now functions. And in JavaScript, functions are the most powerful thing. Like, we can take advantage of anything now. Closure scope or arguments, so we can parameterize the mixin with arguments. And of course, context. As I showed, a mixin can be applied to anything, prototype, an instance, or anything else you can think of. The advice feature, again, kind of repeating myself, allows you to augment functions instead of clobbering them. And the most fundamental point about these mixins is they work with the language. So now none of the shenanigans that the class syntax that we showed before, had a lot of behind-the-scenes stuff just to make a familiar syntax work. Instead, you just call the thing, you call it in the context, and it actually works. It's very transparent, easy to understand. There's no surprises. So now, I'm going to hand it back to Han, who's going to talk about how we put this functional mixins to work on the twitter.com site.
Hello, I'm back. So yeah, now we sort of talk through these two separate but very linked and very useful together concepts of before, after, and around, what we call advice. There's lots of other names for that, for those common functions, and how they work together with our functional mixins. I'm going to show you just how elegant things can be and some of the consequences of the things we've just shown you on an actual real chunk of code that's out of twitter.com. So the piece of code I'm going to show you is actually a wrapper for local storage. So you're probably aware that local storage exists in most browsers, but it doesn't exist in all browsers. So what we wanted to do is basically add a wrapper layer that smooths away the browser differences. And doing that was made really, really easy by using these the techniques that we've been talking about. So this is our sort of basic storage layer. We create a constructor. As per usual, all the constructor does is it knows to initialize itself, and it just passes through these arguments to an initialize function. Now, underneath that, we have the base storage, which is our sort of a mixin that creates all of our most basic functionality that exists across all kinds of storage. So we have an initialize method, and literally that's all that's doing is setting some kind of namespace. So we can have various storage namespaces that point to different sets of information. It also has encode and decode methods. So we know that when we put something in any kind of storage, we need to stringify it somehow. So we use JSON. So we encode it to JSON on the way in, and we decode from JSON on the way out of whichever storage we use. But the really interesting bit is because, as we said, our mixins aren't just a property copy, they're actually a process, they're a function, then we can do some really interesting stuff. So as you can see, what we do then is within this mixin, we execute some function detection, some feature detection, and actually mix in another mixin, which is the correct storage engine for that browser. So we'll say, if we detect that local storage is there, then we mix in the local storage engine mixin. Otherwise, we might detect that we're in crazy IE land and mix in crazy user data engine. And finally, if we don't want to do any of that, we can fall back to a simple memory storage mixin. Then the last little bit is we'll mix in our with advice, which will give us the before, after, and around methods, which we'll make use of soon. And then we mix base storage into the prototype. So we now have this storage constructor, and we've built this basic prototype. So let's have a look at an example of those storage engines, these swappable storage engines. They're pretty simple, really. I mean, all the contract is here is that a storage engine has to have a get item and a set item, and it just contains that specific implementation. So in this case, for local storage, we do the really simple stuff. We use local storage's get item, and then we decode whatever comes out of that, and for set item, the reverse. Then if we look at another one, I'm not going to show you the user data version of this because obviously it's a proprietary Microsoft atrocity and no one wants to see that. But I'll show you the memory one. So this is just a completely alternative implementation of the same two methods. One thing we've done here is we've used after to actually add a little bit of initialization that's specific to this mixin. The nice thing about this is that the base storage object needs to know nothing about what this is doing. It's self-contained. It handles itself. And then, yes, we've got the alternative implementations of get and set item. So that is really, really nice. But what happens if now we've got our basic sort of cross-browser storage that we wanted to implement an encrypted storage? Well, we just write an encrypted storage mixin that we can mix into this base storage we've created. And that might look something like this. So what we do first is we augment the initialize function to take not only a namespace, like the normal one, but a secret, and we store that secret. And then what we can do is actually use around to augment our decode and encode things. And what you're seeing there is the first argument. If you use around, the first argument of the function you pass into it is actually the original function that you're augmenting. So you can choose to call the original function and then do some other stuff with the return value, or you can do all kinds of stuff with it. So what we're actually doing is we're augmenting the decode, and we're saying, as well as doing the old decode, which is just a JSON decode, we're actually, before that, going to do our AES decoding. And then similarly for encode, we say we're going to do the original JSON stringifying, and then we're going to encrypt it. And then these methods get used by the set item and get item that we saw before. And this is all we've had to do to actually add encryption ability to storage. And the really nice thing is we've got flexibility here. So in the bottom two lines of this example, we say, okay, well, we don't want every single local storage usage on our site to be encrypted, but we want this one. This is our secret stuff. So we create an instance of our storage object and just mix in the encryption to this. But obviously, if we wanted to make all of our storage encrypted, then we wouldn't have to change the mixin. We just mix the same thing into storage's prototype, and then all storage would be encrypted. So yeah, this is just a very sort of simple demonstration of what you can do with this stuff. So in overview, we've talked about these two separate but really complementary things: functional mixins and advice. And I think we have been using this stuff really heavily, and we think it's really, really, really elegant. I think it makes use of JavaScript's biggest strength, as we said, which is functions. You get all of the power of functions applied to this problem of reuse. Because we're going with the flow of JavaScript, and we're not having to come up with some hacks to, like like you do with class implementations to make super work like you would expect it to work in another language. All we're doing is using the bare bones of JavaScript. So it's extremely simple. The other thing is, because we're using functions, it's endlessly flexible. These mix-ins aren't a process. They're actually, they're not a property copy. They actually are a piece of running code, and you can do all kinds of things in that mix-in if you wish. I think we definitely found there's massive advantages over using this over any of the class implementations, and it just keeps everything really simple, but allows you to make some really nice self-contained reusable code. So with that, are there any questions? The question is are the before, after, and around something we implemented? Actually, we do have our own versions, but they're basically the same as the ones that are in _JS and implemented in various styles. So yeah, they're very simple. We perhaps should have shown those, but yeah, pull them out of _ if you want to use them. So can you say that again? So the question is, if you are using a lot of this stuff to override things, stop me if I'm paraphrasing wrongly, are there any performance or issues or redundancy? There could be. I mean, obviously, you could be wrapping a single function over and over and over again, and creating lots of function executions. Would you like to?
Yeah, I think there definitely could be issues, but I guess it's no different from like classical inheritance. If you call super and classical inheritance, there could be the same issue, right? There could always be that issue in programming. You have a property, your super function does something else to that property. I think it's always a concern we have to look out for.
And then finally, we, for clarity, just showed you the version. You're just using Croll to actually apply a mix-in. What we actually do in practice, and what we do in lots of places in our code base, is make a lot of use of assertions. So we have we wrap that process in some like development time assertions that say that will like hard error if we try to clobber if we accidentally clobber something, and various other circumstances. So, and then all of that code never gets run in production. It's literally developer time assertions that help catch weirdness, and that really helps. So the question is, how do we protect from accidentally clobbering things? What I just suggested is how we do that. We have runtime assertions that actually hard error when you one mix-in accidentally clobbers another one, because we assume that you don't want to do that. So as you're writing the code and as the tests are running, then we make that hard error, and then all of that gets pulled out at production time, so we don't spend the extra cycles checking that stuff, but we still do have the checking. So the question is, how hard is it to test? So the architecture that we run is actually designed to be extremely easy to test. I don't think that this feeds into whether it's hard or easy, actually. the way that we do things is we have a completely sort of separated component architecture, and every single component only communicates via event, so and is kind of completely meaningful on its own. So then we just isolate each individual component and basically fire events and see what it does. Yeah. The cool thing is they end up being really self-contained. So what we do is we just mix them into an empty object, so it's just those methods. And you have a really nice way of testing just that mixin on its own. Yeah, so there might be, but our approach to performance is we wait until we have a problem and then we solve it.
Yeah, that's absolutely right. The other thing that's kind of important to note is this is only when you define the components, when you're first defining the prototypes. So you only mix those things in when you load the thing. It's not like every time you call a function, it's going to be going up the mixing chain. Some ways it's actually, once you've loaded that stuff, it's actually improvement over prototypical inheritance because there's no chain you need to traverse. Everything is mixed into that one instance. Basically there, yeah.
I think that being said, there could be problems. I think you're totally right. Like, if we use that advice to the nth degree and one method is wrapped 15 times, then you've got this giant stack to run through. And I think what we would do is if we profiled and we found that that was a bottleneck, then we would just refactor to get rid of that. So, but we've not found any problems in general. But that would be our approach if we did. So the question is, do we rules, right? So the question is, do we have any rules about what before, after, and around do? So before and after can't change the arguments or the returns. That it's like impossible for them to do that. However, around can do everything. And we tend to use around very, very sparingly. It's normally before and after, because normally you just want to kind of have the mix-in sort of initialize itself, add event handlers that it needs, and so on. And I suppose the case that I just showed was trying to use everything, a case that uses everything, but using around is not it's not a normal thing. But you have that power. Okay, so I'm trying to think of a brief way to paraphrase the question. So, how's your? Oh, okay.
I think what you're saying is, can you add a mix-in to a mix-in? Can you apply a mix-in to a mix-in? Yes. Okay. Yes is the answer, and we definitely have examples of that in the Twitter.com code. We also optimize that a little bit because then you have the potential that the same mixing could be added twice, like the chain could get complicated. So we just have a simple hash object that keeps track of all the mixins that your target object is currently representing. Don't bother to load it if it's already been loaded through some other path.
Yeah, that's one of our kind of develop time only assertions that we run that never run in production. Go ahead.
Do you ever use that to make like composite mix-ins where one mix-in, all it does is add in 5 others?
Yeah. Or we do stuff like that where we conditionally pull in other mix-ins depending on the environment that it's running in. So. I'll do the slide. Okay, is that all good for questions? Any more? Okay, cool. Well, oh no. So I'll do the company thing. So yeah, we are doing some really damn good stuff on the website at the moment. It's been a great opportunity to sort of rethink everything, like I said, and we're working with lots of interesting new stuff. And we need some help on the web team and on other teams at Twitter. We have a booth that has like some like wooden pens and all kinds of. It's got Canadian Twitter stickers. They're good. So come and chat to us. We'll be hanging around there. You know, if you want to talk about anything we're up to or give us abuse or whatever. Twitter.com/jobs is where the jobs are at. We're doing like a happy hour thing tonight that you have to sign up for, and it's full. But like, if you've signed up, we'll see you there, and it'll be cool. I'll be DJing. And then after that, Beer.js is happening, which we're all going to a bar to drink, talk about JavaScript. And yeah, wicked. Thank you.